long-range communications in unlicensed bands. The rising stars in the IoT and smart city scenarios by Marco Santangelo, Lorenzo Evangelista, Andrea Zanella and Michele Zorzi from IEEE Wireless Communications, Volume 23, October 5, 2016, page 60-67. Internet of Things paradigm refers to a network of interconnected devices such as sensors, actuators. Multi-offshore range transmission technologies include Zigbee and Bluetooth. They consume very low power consumption and have limited coverage. In wireless cellular network, they revamp 2G or GSM to 3GPP to support the IoT traffic. Latest cellular network includes UMTS and LTE. Alternative solution is low-power wide area networks, characterized by long-range radio links and star topology, wide area coverage and good connectivity. The IoT paradigm does not have any restriction on the type of technology for connections between end devices to the internet. It is true that wireless communication is the only practical solution for many IoT applications and services. Dedicated protocol stacks were designed to cope with the limitation of the end devices, and it is mandatory for at least one device is needed to be connected to the IP network, serving as a gateway for the other nodes. The application will run locally in the subnet or using cloud computing services. The IoT platforms act as a unifying framework, enabling the service creation and delivery, as well as the operation, administration, and maintenance of things, and the gateway. The common IoT standards includes NFC, RFID systems and etc. Key features for mesh networking will be providing resilience to the failure of some nodes, and it requires non-negligible control traffic for maintenance of mesh network. Also, multi-op routing produces long delays, unequal and unpredictable energy consumption among the devices. For short coverage range high data rate, they tend to favor the data rate rather than the sensitivity. They use a relatively high raw link bitrate, about 250 kilobits per second, to recover from the network delays due to mesh networking. However, they are not robust enough to penetrate through building wall and obstacles. Low-power wide area network or LPWANs are wireless telecommunication networks designed to operate in various unlicensed ISM bands. They have large cellular-like coverage ranges, realized by an advanced physical layer targeting high receiver sensitivity. LPWAN suffers from low data rate, and since smart city and IoT services only generate tiny packets of data intermittently, and are tolerant to delays and packet losses, they can leverage on LPWAN, where the drawbacks are not a factor. For LPWANs, end devices are connected directly to one or more gateways, similar to traditional cellular network, and thus existing infrastructure can be reused. LPWANs utilizes a star topology, allowing greater control of connection latency. It also functions as a point of access for end devices to the IP-based core network. LPWANs inherits basic aspects of legacy cellular systems architecture, and the simple but effective topology allows it to support services such as the smart city. Three prominent technologies for LPWAN include Sigfox, NGNU, and LoRa, operating in the unlicensed ISM band and can handle large amounts of connected objects. In the LoRa system, it consists of 6 components. We shall look at some of it in details. The LoRa have 3 classes. They are Class A, Class B and Class C, each associated with a different operating mode. Class A networks are mainly intended for monitoring applications, where the data produced by the end devices have to be collected by a control station. Class B is intended for end devices that need to receive commands from a remote controller. Class C is defined for end devices without energy constraints, hence keep the receive window always open. In LoRa IP connectivity, because LoRaWAN employs the IEEE 64-bit extended unique identifier to automatically associate TIP6 addresses with LoRa nodes. TIP6 protocols can be deployed on LoRaWAN networks, thus enabling transparent interoperability with the IP-based world. Finally, we shall take a look at the security in LoRa. In security, several layers of encryption are employed. Unique network key, unique application key and device-specific key. A LoRa network was installed in a 19-floor building. Other communication technologies needed repeaters on each floor, while LoRa needed only one gateway, serving 32 nodes installed around the building. A coverage analysis was done in Putaba, which has tall buildings and a busy traffic, spanning 100 square kilometers. With a range estimate of 1.2 kilometers, the city can be covered with 30 gateways, less than half installed by a major cellular operator. One gateway serves 7,000 people, although the maximum is 15,000. This means it is 2 things per person. In the future, it is expected to be 6 to 7 things per person, sufficient for smart city applications. In conclusion, the emerging LPWAN paradigm was discussed for use in IoT connectivity, which includes Sigfox, NGNU and LoRa, different from the usual IoT topology. The LoRa deployment test showed that LPWAN is applicable for smart city applications. Sisley bin Mohammed Ali. Leo K. Howe. Ali 1. Mohammed Darif bin Hamran. Tayway Kayan.
Created using Powtoon.